Hi there and welcome back. On today's video, we are going to look at linearization with Taylor series. We are going to linearize few functions. Linearization is the process at which we approximate nonlinear systems with linear ones. We are going to use Taylor series to make nonlinear functions linear. For start, let us take the Taylor series equation and write it down. We are going to say f of x is equals to f of f0. f0 being the point at which we want to linearize plus the derivative at x0 multiplied by x minus x0 with a factorization of 1. The equation continues more terms the second derivative at point 0, x minus x0 over factorization 2 and x minus x0 is squared. The equation can continue, but we are going to stop here, so hence I'm going to say plus dot dot dot. Now that we have defined our Taylor series equation, let us start and linearize our functions. The first function we want to linearize, it's 5 square root x. Now to explain this on a simpler term, if you look at our function versus the Taylor series function, f of x, in this case, f, it's the 5, and the x, it's the square root of x. And we are told to linearize at point x0. We are going to start by approximating using the Taylor series. For each term, substitute accordingly. So for the first term, we are going to have 5 square root x0 plus 5 over 2 square root x0 x minus x0. The function can continue, hence I'm going to say plus dot dot dot. Let us continue again. We are going to linearize lin y at point y0. We are going to say lin y, approximating the root using the Taylor series. Lin y0 plus 1 over y0, y minus y0. Let's do the next one. Linearize the function f of x is equals to square root of x at point x is equals to 4. We are going to linearize this function. In this case, our f is 1 and the x, it's the square root of x. By substituting the first two terms, we are going to have x0 plus 1 over 2 square root of x0, x minus x0. Substitute the point at which we are linearizing at. In this case, it's 4, and you can also substitute further. You can also do the same thing, linearize for y squared at y0. Remember that the derivative of y squared, it's 2y to the power of 1, hence we have 2y not 0 there, and you can also expand further or substitute further. Lastly, substitute cv square root of h at h0. You can approximate using the Taylor series for the first two terms, and it should give you cv square root of h0 plus cv over 2 square root h0, h minus h0. I really hope this makes sense. Let me know if you have any other questions. Thank you so much for watching.